Just kidding, guys. I'm not really underwater, okay? I'm at my kitchen table. It's late at night, trying to get this video going. Screencastify wasn't working, but now it is. So today's objective, graph and transform quadratic equations, all right? So the only thing we can really do is kind of make them stretch, compress them, shift them left, shift them right, flip them, and then move them up or down. So it sounds like a lot, but to be honest with you, I think today's lesson is going to be really, really helpful to your grade because I think we're going to understand it. All right, so the very first thing we need to talk about is this parent function or parent graph. It's the simplest parabola. It's y equals what? Y equals x squared. So again, remember, it's the simplest form due to the fact that all we need for a parabola to graph is that x squared term. So there's no linear term, the x term, and there's no constant term. All right, so this is the parent function. If you look, it passes through the origin, which is that 0, 0 point, and it's contained in quadrant 1 and quadrant 2. All right, so again, this is the parent function. This is the original function that we're going to be talking about. All right. So transformation review. If you look, what we want it to be in is, once again, vertex form. Remember, the vertex is HK. All right, so this is the x value. It's actually the opposite because that negative of the x value of our vertex, and then k. And then A we're going to get based off of the equation that's hopefully going to be in standard form. All right, so again, it's the parent function that we're going to go off of, which is this right here, x squared. And then we are going to transform it, and what we're going to do is talk about these A's, the H, and the K's. All right, so we're going to have 4 things that could potentially happen here. All right, so the first transformation is what we call a vertical stretch or a vertical compression. Okay, stretch means we're going to make the graph skinnier. Compression we're going to make it wider. All right, so let's look at that slide. It's all about the A term. So the very first transformation actually isn't going to be the stretch or compression. It's this note right here. It's pretty quick. When A is positive, remember those arrows point up. And when the A is negative, they point down. So I do have that right here on this slide here. You can see that my smiley face is the blue. So this blue smiley face is when it goes up. That's his smile. And then when it's a frowny face, it points downward. So you can kind of see, here's my negative out front, and then my positive is just intelligently lazy. We don't put the plus sign. All right, now to go back to this slide is when we have stretch, it means that A is greater than 1 or it's less than -1. Either way, it's going to be like an absolute value, let's say, of greater than 1. All right. The other part is vertical compression. If you look here, there's a compound inequality where it says A is greater than -1, but it's also less than 1. What's a way to say that? It's the F word, the dreaded fraction, okay? So if we have a fraction or a decimal in front of that set of parentheses, it's going to get vertically compressed, which means it's going to get like smushed from the top and the bottom, so it's going to get wider. And if we have a number that's going to be greater than 1, or the absolute value of 1, I should say, that's going to be stretched vertically, so it's going to get skinnier. And I'll show you what I mean here in a second. So here's the stretch. Again, we have it's greater than 1 or it's less than -1. And my parent function is in blue, right? So here's my parent function, my OG, my original function. And now you can see that here we're getting wider. So this is the compression in red is where it's getting wider. And you can see that I have fraction there. They have it inside parentheses. Normally it's going to be outside of the parentheses, but that's because that's in standard form actually. So if we're looking for it, we're again looking at this a value. If it's a fraction, it's going to be compressed, okay? If it's going to be a stretch, we're going to pull it from the top, and that means this a value is greater than 1, or it's greater than, or is less than -1. Either way, that absolute value is going to be greater than 1, okay? So again, the blue function is our parent function. The green one is getting stretched vertically, so it's getting skinnier. And you can see that here. Again, this is in standard form. However, we're going to have this 4 outside the parentheses, and it will look like that instead with the 4 there, okay? And that being squared. Any questions? Again, pause, rewind. We're going to go over a few examples. Hopefully we are not there yet of not understanding what we're talking about. But again, compression is going to be a fraction. Stretched is going to be a number that's greater than 1 or less than 1. But it's going to be that coefficient that's going to be out in front of the parentheses. Horizontal shifts, which means go right or go left. Okay, this is kind of a little bit backwards, but we're going to figure it out. Here, we're looking at that h value, okay? So, if inside of parentheses is negative, okay? If this is negative, we're shifting to the right, all right? If it's positive, we're shifting to the left. And if you look here, the reason why it changes to a positive is because it's always, that skeleton model is always negative, or take the opposite of h is what we like to say in class. So if my value is -2, what's the opposite of -2? That's +2. But -2 on the x-axis means go left. So although it says +2, because we're doing the opposite, okay? And when this says -2, that means we're shifting 2 to the right because it's actually the opposite of +2, right? It says -2. So again, we're going to practice that, but it's inside parentheses. If it's negative, it goes right. If it's positive, it goes left. And we're going to show that real quick right here. Again, you can see that here I have a +2 inside of parentheses, so it's shifted 2 spots to the left. And on the other one, I have a -4 in there. If it's negative, it goes right. So it goes right 1, 2, 3, 4 spots, okay? And again, that parent function is always that function that's in the middle here that goes from the origin, okay? So we shifted this to the left. Again, left is what? Positive. And if we look here, if it's negative, we're shifting it right. And again, we are talking about inside right here of parentheses. All right, so if it's negative, it means go right. If it's positive, if it's negative, go right. If it's positive, go left. Vertical shift up or down, okay? So if you've seen, we've talked about the A, we've talked about the H now. Now it's time to talk about the K. So the K, if it's positive, goes up. If it's negative, it goes down. So here, our skeleton function means it's going to shift up in vertex form. And again, this negative would mean go right, but we need to figure out what our H and K are when we talk about this, okay? So again, this is the opposite of H because it says -H. So if you look here, it's real simple. I have blue pen right now, so we have, here's my standard form equation. It says +4, so we're talking about that K value. Anytime it's positive, it goes up. So from the origin, from our parent function, it goes up 1, 2, 3, 4, and we're good there. And then if we look at the negative part where it goes down, if K was negative, we go from the origin, from the parent function, down how many? Down 4, because it says -4. 1, 2, 3, 4. There we go. So again, all these letters do something, right? They mean shifts. Is it wider? Is it narrower? Is it left? Is it right? Is it up? Is it down? Is it flipped? That was the first one. So here we go. Again, looking at it in vertex form. Here I have my parent function, my original function. That's as generic as it can get. Okay, it goes to the origin. So translation, if it goes left to right, is based off of the h value, which is inside of parentheses. All right. Left is positive, right is negative. Vertical compression or stretch, depending on how large or how small of a fraction that could be. That means it's going to get stretched or compressed. Reflection, that just means to flip it. That's also going to be on the a value. Positive goes up, negative goes down. And then the translation is actually shifting the graph up units if it's positive and down units if it's negative. So let's take a look at it. I've already made a quick little guide for us to go off of. So hopefully that'll help us. So what is the smiley face? That means it points up, right? What is the negative face? It points down. How do we know that? It's from the a term. So because it's positive 4, it's going to be a smiley face. We're going to be smiling, all right? The next question is it being stretched? That value is 4. Is that a fraction or is that a nice whole number? All right, if it's a fraction, it's compressed, but since it's a is greater than 1, it's going to be a stretch. If we look here, inside of parentheses, does that say plus or minus? It says minus, so I'm looking at this -2. That's going to go to the right. And last but not least, I'm going to go looking at this k value, and it's +7. So anytime it's positive, it's going to go up. So our transformation is it points up, it's getting stretched vertically 4 units, and then it's going to get shifted to the right. How many times? Twice. And then it's going to get shifted up 7. So there's a lot going on to this equation in vertex form. All right, let's try another one. All right, again, smiley face or frowny face. It depends. What's it depend on? It depends on if this is positive or negative. Since it's negative, negative people normally have frowns on their faces, so it's going to be pointing downward. What's the stretch based off of? The stretch is based off of the value, the a value in front, which is 1/2, because I've already dealt with the sign with the smiley face or frowny face. Is that a fraction? If it's a fraction, it's being compressed, so it's going to be wider. Now I'm going to look inside of the parentheses. Is it positive or negative? Since it's positive, remember we're taking the opposite of what the vertex was there, so it's actually going to be -1. So we're shifting this to the left. And last but not least, let's look at the k value. What's the k value? That's -3. So it means shift 3 units down. All right. So I have everything written out here as far as so I don't have to write it all. I kind of put that in a Word document and then just copied and pasted it to make it quick. So let's look at another example. The item outside or the sign outside is going to be negative. So that is going to be a frowny face. Do I have anything outside as far as a number, coefficient-wise? I don't. So that's not going to be stretched or compressed because it's 1. Okay, it's still going to stay that same width. Now, is it going to get shifted left or right? That depends on what's inside here. It says -17. So that means if it's positive, it goes left. It says negative, so we're going to go right 17 units. And then do we shift this up or down? Is there a k value out here? Nope. So there's no shift here, and there's no compression or stretch here. So we're only flipping it, so it's pointing downward. And we're going to be shifting it to the right 17 units. That's supposed to say units, but it didn't come out right. Any questions? The last example is going to be in standard form. So what do you have to do with standard form? If you've noticed, I've already put our clue up there, our best friend, our BFF. Best friend forever is Desmos. So I've already uploaded that to Desmos, 2x squared minus 8x minus 3. If I look, I have vertex form over here. Again, anytime I have vertex form, we're going to say y equals space, parenthesis, x, space, space. What do we have to put here? My h and my k, and then my a. So where am I going to get the a value from? My a value comes from the standard form. So I know that this is going to be 2. So when I write this in vertex form, I get y equals 2, parenthesis x. Now where do I get my h and k from? My h and k come from Desmos. So I'm going to look at my graph. I'm going to have my important points come up here. Here's solution number 1, an ugly point. Solution number 2, so this has 2 solutions, 4.345, another pretty nasty looking point. Oh, my y-intercept's not too bad, 0, -3. And then last but not least, my vertex, 2, -11, which we're going to be putting in vertex form. So my x value again was 2, and -11 was my y. So I plug in, it's always minus, because it's the opposite of the h term. So it's -2. And then my k is -11. So I have my vertex form to tell about my shifts. So again, if I look here, I'm just going to bring this up. Maybe if I can copy this real quick. I'll bring it to this last page here. All right. Shrink it. Based off of my information that I have here, am I going to have a positive smiley face or a negative smiley face? Or a negative face, I should say. Because this value is positive, I know it's going to be happy. What's the value for the stretch or compression? It's greater than 1, so I know it's going to be a what? A stretch, so it's going to get skinnier. Is it left or right? Left or right's inside of the parentheses. If it's negative, we're going right. How many spots? 2. And last but not least, we are going to look at our k value, which is -11. And that means go down 11 units. All right, so I'm going to circle my down. Okay, other than that, it's a pretty quick unit, and we need it to be in vertex form. We can easily transform it from standard form into vertex form by using Desmos, and we do need that a value right here. We could solve for it if we didn't have it, but since it's in standard form, we're going to take that a value from the standard form. Again, other than that, this is a pretty quick section. So hopefully you understood it. And if you didn't, again, pause it, rewind it, replay it, shoot us an email, and we'll get back to you in class, ask questions. Other than that,